Let's take a look at our next example, 5. It says create an identity for expression 2 tangent theta. Let me write it down right away. 2 tangent theta, secant theta, by rewriting strictly in terms of sine. Well, let's try that. So what is tangent theta? Tangent theta is sine theta over cosine theta. But then I have 2 of them, right? So it's 2 times. And what is the secant? Secant is 1 over cosine theta. All right. So multiplication of fraction tells me I need to multiply the numerators and the denominators. So I'm going to get 2 sine theta in the numerator and cosine square theta in the denominator. Okay, in the problem, they tell me to rewrite it strictly in terms of sine. So I know that cosine square is 1 minus sine square theta. So I'm going to apply that identity. And I'm going to have 2 sine theta over 1 minus sine square theta. And this is it. We actually completed this this example. It says rewrite strictly in terms of sine, which we did. That's it. We cannot simplify it anymore. What we could have done, we could notice that this is a difference of squares, and we could also write it as 2 sine theta over 1 plus sine theta divided by multiplied by 1 minus sine theta, but this is it. And we know that this whole thing, it equals 2 tangent theta secant theta. So that would be in our identity. Well, let's continue, and we're going to proceed to example number 6. So again, I'm looking at the left side, and it's more complicated than the right side. So I'm going to start with the left side. And I'm going to actually write the square outside the parentheses here. So we have a sine of negative theta squared minus cosine of negative theta squared, right? Divided by sine of negative theta minus cosine of negative theta. So what I'm going to do first, I'm going to apply my even and odd identities, those function properties. So since sine is an odd function, it's going to become negative sine theta squared. And a cosine is even function, so this negative is going to be absorbed. So minus cosine theta squared. So the same thing happens on the bottom. Negative travels on the outside for the sine, and it's absorbed by the cosine. All right, so moving on. I'm looking here thinking, what else can I do? What else can I apply? And I noticed that here I have my a squared minus b squared situation, right? By the way, before I actually do that, I'm gonna actually square my sign, negative sign. When we square negative sign, it becomes positive sine squared, right? So that negative goes away, minus the cosine square theta. And on the bottom, what I'm gonna do, I'm gonna factor this negative sign outside from the denominator. So sine theta plus cosine theta. Now, again, some of you will ask at this point, how do you know that's what you have to do? I don't. I just do what I see it can be done, and then hoping that it will lead me in the right direction. If not, then I'm gonna start over again. Okay. So here I have a squared minus b squared situation. And we know from algebra that if we have a squared minus b squared, that equals to a plus b multiplied by a minus b. So I'm going to apply this formula here, and I'm going to rewrite the numerator as sine theta minus cosine theta multiplied by sine theta plus cosine theta. Okay, and on the bottom, I have negative sine theta plus cosine theta. But look, I have a factor of sine theta plus cosine theta in the numerator, and that will cancel out with that same factor in the denominator. And notice this is not just negative, this is just an invisible -1 there, which is gonna stay in the denominator. So what do I have? I have sine theta minus cosine theta in the numerator and a -1 in the denominator. So I could bring this negative to the top or to the front of the fraction, or I could just multiply the top and the bottom by that -1. And what am I going to have? Well, factoring the -1 in, I'm going to have negative sine theta plus cosine theta over a +1, which let's write it down. Okay, now in order to make it pretty, I'm gonna switch the terms. I'm gonna put the positive term first, so cosine theta minus sine theta, and that's exactly my right hand side. So of the identity. So we did prove it. And I want you to practice what you just learned and try it by yourself. Here you go. Please pause the video here and try and to verify this identity. So I hope you successfully verified the identity. Now let's, the last example that we're gonna do in this video is example 7. So let's tackle this identity. And again, we're gonna start with a more complicated side, which is the left side. We have 1 minus cosine square x multiplied by 1 plus cotangent square x. So what can we do? Right away, I see a Pythagorean identity staring at me. So 1 minus cosine square x is the sine square x. Also, since I'm gonna have a sine square x, I'm gonna rewrite my cotangent square as cosine square x over sine square x. And what do I have? I'm gonna have sine square x over 1, because I'm getting a fraction here, multiplied by 1 plus cosine square x over sine square x. All right, what else can I do? Well, I can factor this sine square x inside this parenthesis. So I'm gonna have sine square x over 1 multiplied by this 1. I'm not gonna write multiply by, well, actually, we could. And then I also have plus sine square x multiplied over 1 multiplied by cosine square x, right, over sine square x. Well, since we have multiplication sign here, I can cancel common factors over multiplication. So I'm left with sine square x over 1 plus cosine square x over 1. Well, you see that that's the same as just sine square x plus cosine square x, which again is a Pythagorean identity. So that just equals to 1. And that's my right-hand side. So I am done proving this identity.